Coconut College of Engineering and Technology, Department of EEE, Subject Code 20601 for System Operation and Control, Unit 3, Reactive Power Voltage Control. So these are the topics we are going to discussing about this reactive power voltage control, generation and observation of reactive power, basics of reactive power control, excitation system modeling, static and dynamic analysis, stability compensation, method of voltage control, tap changing transformer, SVC, static power compensator, and StatCom, secondary voltage control. Excitation systems, exciter ceiling voltage, excitation system ceiling voltage, excitation system requirement. The requirements meet specified response, must be able to prevent damage, good operating flexibility, and reliables. Types of excitation system: DC excitation system, AC excitation system, and static excitation systems. DC excitation system, this used to DC generator as a source of excitation power and provide current to the rotor of the synchronous machines. So it may be either self-excited or separately excited DC generators. AC excitation system, this excitation system utilizes alternators AC machine as a source of main generator excitation power. Static excitations, all the components in these are static or stationary. Static rectifiers, controlled or uncontrolled, supply the excitation current directly to the field of the main generator through slip rings. This block diagram of static excitation systems. First one is exciter transformer. It is a 3-phase AC supply is given. The output is connected to the controlled rectifier. The rectifier is converted AC into DC supply. Again, the DC supply is connected for the slip rings. The slip ring is connected for field winding of the main generator. The armature is connected to current transformer and potential transformer. This both supplies connected for AC regulator. It will be regulate the AC supplies with the connection of AC reference voltages. And then regulator transformer, DC regulator and the DC reference, a controlled rectifier, excited transformers. So this block diagram is considered as static excitation systems. Next one, automatic voltage regulator or typical excitation systems. Here we are going to deriving for this one excitation brushless modeling. So first one, comparator. So compare the reference signal and then input signal. The comparator output is given to the one of the amplifier. It will be boost the signals. The amplifier output is connected for the excitation of input. That means here DC supply is given for these excitations. This excitation is again connected for this one rectifier. This rectifier is converted AC into DC. The DC supply is finally given for this generator field windings. The generator output is connected to one potential transformer. The potential transformer another devices is connected for rectifier and the filter circuits. First one, brushless AVR. The 3 types of excitation system. Earlier we are going to discuss the DC excitation, AC excitation and static excitation systems. The 3-phase alternator with rotating armature type and the stationary field winding type, we have to choose an 3-phase armature on the rotor and the field on the stator. The AC armature voltage is rectified by diode bridge mounted on the rotating shaft and then fed directly into the main generator field. Next one, modeling of brushless AVR. Potential transformer and rectifiers. Potential transformer, the terminal voltage of the generator is stepped down to the value required for the control signal and then rectified to get DC voltage proportional to the RMS value of terminal voltage. Comparator, compare the measured signal V and against the reference DC signal V reference. The difference between these two signals produce an error voltage VE called error signals. The error voltage we are going to taking for this modulus of V reference and modulus of V, that means magnitude. This above equation we are going to taking Laplace equation. This Laplace equation we have to finalizing for the block diagram of comparator. Comparator comparing the reference signal and the magnitude signal, we can getting the output. This output is connected to the amplifier input. The amplifier amplifies the input error signal depending on the amplification factor. There are various types of amplifiers used in excitation systems. Next one, amplifier transfer function becomes amplifier gain is equal to Ka divided by 1 plus STA. That means amplifier model. So the model of amplifier is shown in the block diagram. The typical value is constant, means 10 to 400. Exciter. The purpose of exciter is to supply the field current to the rotor field of the synchronous generator. Here the circuit and exciter for the separately excited DC generator. This is connected for this equivalent circuit for this RE and LE. So RE is exciter field resistor, LE is exciter field inductance from the equivalent circuit. Synchronous generator generate 3-phase AC power at terminal voltage. The terminal voltage of the generator is maintained constant during its varying load condition with the help of excitation systems. The terminal voltage V of the generator equal to the difference between induced EMF E and drop across the armature. So del V is equal to del E minus V drop. The relationship between Vf and V depends on the generator loading. The synchronous generator model is shown in below. So del V of F into the model is Kf divided by 1 plus S T dash T0, that means del V, the model of the generator. So all the block diagrams we are going to combine together. We can draw this one closed loop model of automatic voltage regulator. So here comparator, compare the input signal and the output signal. Which one is the best signal? It will be connected for this amplifier input. The amplifier model is Ka divided by 1 plus STA. The amplifier output is connected to input of the exciter del VR. So Ke divided by 1 plus STE. The exciter output is connected to generator input. The generator input del VF is given the input side, and then the generator Kf divided by 1 plus S T dash D0. This is the closed loop model of automatic voltage regulator. So this block diagram we have to reducing for this block reduction technique. The reduced model is shown below for this del V reference. Ka, Ke, Kf divided by 1 plus STA, 1 plus STE, 1 plus ST dash D0 del V. For this open loop transfer function, we can using for this Laplace transform of this given system. So transfer function of output divided by transfer function of input. So G of S tends to del V. So V reference is equal to G of S divided by 1 plus G of S del V. So open loop transfer function G of S equal to K divided by 1 plus STA, 1 plus STE, 1 plus ST dash. Next one, static analysis of automatic voltage regulator loop. That means a steady state response. So the same block diagram of the comparator, amplifier, exciter, and then final one, generator module. So these closed loop module, we are going to derive the initial error conditions. Again, we are using to apply the block reduction technique. We can find out the open loop transfer function of this above block and the initial condition. Reference voltage is 0. We can find out the 1 by 1 for static accuracy and the specifications. So this value we are going to reduce the 1 by 1 and finally applying the final value theorem. So the S terms we can using for this 0. That means del V static condition is equal to limit S tends to 0 S dot del V of S. So finally we can find out the K divided by 1 plus K. Next, dynamic analysis of automatic voltage regulator using AVR loop. So comparator, amplifier, exciter, and then regulator. So these finally we can reduce the again block diagram of AVR loop. For the above diagram, we can find out the open loop transfer functions. So these open loop functions, the final value del V of t is equal to L inverse of del V of S. So here applying for case 1, roots and real and destinies. So find out the K1, K2, K3 value. So K1 divided by S minus S1 plus K2 divided by S minus S2 plus K3 divided by S minus S3. Case 2, the two roots or eigenvalues are complex conjugates. So the next one, stability compensation. The stability compensation improve the dynamic response characteristics without affecting the static loop gain. Even for a small amplifier gain of Ka, that means automatic voltage regulator step response is not satisfactory. We must increase the relative stability by introducing a controller which would add a 0 to the AVR open loop transfer functions. So again the same block diagram, we are going to reduction for this dynamic response, comparator and then amplifier and exciter and then generator modules. So here it will be connected for the series compensator with the unity feedback. The transfer function of series compensator is G of S equal to 1 plus STC. That means series compensator. TC is the compensator of time constant. So the open loop transfer function becomes K divided by 1 plus STA into 1 plus STD and 1 plus TC. So these are all the derivations regarding the dynamic analysis of controlled cases. This is root locus for zero compensated loop, low level loop gain and increasing loop gain. Feedback stability compensation. Consider the addition of feedback stability compensation stabilizer. Even for a small amplifier gain of Ka, AVR step response is not satisfactory. So the block diagram of AVR with the feedback stability compensation is shown below. The block diagram of AVR with the feedback stability compensation, by proper adjustment of Ks and Ts, a satisfactory response can be obtained. Next one, method of voltage control. Method of voltage control: excitation control, static shunt capacitor, static series capacitor, static shunt reactors, synchronous condenser. Other method of voltage controller: tap changing transformer, booster transformer, regulating transformer, and static var compensator and the statcoms. Tap changing transformer, off-load tap changing transformer, on-load tap changing transformer. So this is a definition of on-load tap changing transformers. The on-load tap changing transformers, the input is given for line and neutral, and output is getting for this Q1 and Q2 with respect of switch S1 and S2. So these are all the some operation. we have to reduce and increase the voltage level. Application of tap changing transformer. Transformers with the tap changing facilities constitute an important means of controlling voltage throughout the system at all voltage levels. So some explanations are there. Next one, static shunt capacitors. Shunt capacitor banks are used to supply reactive power at both transmission and distribution level. Capacitors are either directly connected to a bus bar or the tertiary winding of a main transformer. When they are in parallel with a load having a lagging power factor, the capacitors supply reactive power. So rise in voltage of shunt capacitors connected in parallel connection of the given circuit. So E is induced voltage and R plus Jx is the that means impedance value. We have to find out the with and without voltage drop in the capacitors. So here del V dash indicating for the rise caused by capacitor and del V is equal to drop caused by the load. So advantage, less cost and efficiency to be increased. Disadvantages, they cannot be overloaded. Problems, switching inverse current, harmonics resonance problem, limited over voltage. Applications, to improve power factor, improve feeder voltage, power factor correction, feeder voltage, voltage regulations. Methods of voltage control. Static series capacitors. These series capacitors connected in group of capacitors in the transmission line. So the drawbacks. So shunt capacitors and the series capacitors comparisons. It's advantage applications. Static var compensator. And another one, static var compensator using SVC. Then next, types and advantage. So static var compensator, that means thyristor switched capacitor and thyristor controlled reactor. This is a given circuit we can connecting for the transmission lines. So this explanation. So characteristics of DSC and TCR. Advantages. Next is static compensator, that means compensation devices. So another one, voltage source converter, VSC. So working principle and explanations. Features of the STATCOM. Advantage. So the STATCOM using for the compact design and reduce the noise level, harmonics noise, and the magnetic impacts of the given transmission line.